please take a seat. All right. Can you hear me? All right. Perfect. So, ETHWarsaw, my name is Justyna Broniszewska, and I'm co-founder of ETHWarsaw Foundation, and I would like to welcome you to the next meetup. And before we start, I just wanted to show you our roadmap. So you probably all know we had multiple meetups and conferences last year. And I'm also really happy to tell you that this year, in September, we'll also have conference. So I hope to see you there. And of course, I need to tell you that today our sponsor is Ethereum Foundation. So thank you, Ethereum Foundation. All right, so agenda for today is as following. Kuba will tell us, he will give us an intro to MEV. And Kuba, thank you for coming here. And you will probably all know what MEV is today. All right, and after the presentation, we'll have pizza, beer, and networking, as always. So please enjoy the meetup, and you can find us on Twitter and go to our page. We'll update it soon. So thank you. Kuba, the stage is yours. Yeah, big bravo.
So, hello everyone, thank you very much for coming. My name is Jakub, and I'm going to introduce myself first. So, hello everyone, my name is Jakub. I work for Shatter Network for 6 months already, and I joined as an intern 6 months ago, right after graduating from management and AI here in Warsaw. And today's presentation is the intro to MEV, distribution, impact, front running, and how to tame the beast, basically. And thank you very much for coming again. So, how many of you know what MEV is? Hands up. All right. Who thinks that MEV is bad? Okay. Sorry? Oh, it depends. It's just a question. So. And then who thinks that MEV is good? And the correct answer is both. MEV can be good and bad. And what exactly is MEV? So MEV stands from the name of minor extractable value. So basically that stands from the maximum value that, for example, the block producer, the validator, the MEV searcher can make by integrating into the mempool, which is the pre-blockchain state. This is a place where basically all of the transactions come as the plain text, and and for some people they're visible and they can take an opportunity of that. And minor extractable value, actually in Ethereum right now, after the transition to proof of stake, we don't have miners anymore. So right now it's called maximal extractable value. And basically the minor extractable value was first described by Phil Diana. He's a researcher at Flashbots, kind of the main company that is doing research and development in the MEV space. And yeah, he described it in 2019 in his research paper. And yeah. And how basically MEV works. So imagine just a normal situation, just a casual, when you as a sender wants to send a transaction to anyone or just do some kind of swap or basically integrate with the Ethereum blockchain. So basically your transaction comes to the mempool. So mempool is this, as I said before, this pre-blockchain state where transactions come before they are included into the block. And some people, for example, some searchers, some validators, they see the mempool as a plain text, and they can reorder the transactions in order to basically profit for themselves. And an impact of MEV is, for example, very interesting page created by Pimi Guan, the anonymous developer who actually was the first one who described the term of MEV. He said as a first in 2014 that, hey, something like this exists, but not so many people took the attention for that at that time. And yeah, as you see here, at one point, front-running cost around 51,000 in loss in terms of the user losses on the blockchain. And also, the impact of MEV is also visible in terms of the gas spenders. So at one point in October 2022, the MEV was actually made more than a half of the gas spending on Ethereum, because we have to also say that basically validators and the searchers, they front-run transactions. Now they inject transactions into the block first by paying usually higher gas fees. And why is it important? Because the whole point of blockchain is kind of base layer neutrality, right? Like we all use blockchain because it doesn't have any kind of outsourced power, and kind of everyone should be equal. But with MEV, that actually changes, because there are central walls, and there are some people who actually are more privileged, also usually by the knowledge, to actually take the explicit of MEV. But there are also positive impact of MEV, so definitely there are more efficient systems because there are more people who are encouraged to actually run a validator, and that also causes new market opportunities because MEV space is still very new, and that basically market, the whole space, will be much more discovered in the future. And when it comes to types of MEV, basically, types of malicious MEV looks like, for example, front-running. So the trader takes the advantage of knowledge of the upcoming transaction in order to execute their own first by paying higher gas fee. Sandwiching, so the trader creates two transactions, one to buy at the lower price and one to sell. And basically, we can say that he sandwiched this one transaction, and that user that he wants to kind of harm, that he wants to take a profit, for example, from the swap, gets less than was intended to take. And also censorship. Censorship, officially, it doesn't go into the range of actually taking like profit in money in terms of MEV, but some of the validators, they also can not front run, but censor the transactions, and that what also we can call an MEV. And here is, for example, an example of a sandwich attack. So I saw it on the forum, and the person asked, hey, was I sandwiched? And yeah, the correct answer is yes, you were sandwiched. So basically, the transaction of the user who lost money is between, and the attacker basically saw that transaction in the mempool. Firstly, he decided to buy these tokens because he saw that there is a huge swap incoming, so the price will go up. And then afterwards, immediately after that swap is done, the attacker sold what he bought before him. But there are also types of good MEV. So for example, liquidations. So MEV searchers, they can seek for profit opportunities in liquidations. And also, they also can easily seek for arbitrage opportunities between different decentralized exchanges. And now a little bit about MEV mitigation and its distribution. So in the whole space of MEV, I think the most important player right now are Flashbots. This is a research development company that was started, for example, by Phil Diana, the person that described MEV in 2019 and actually gave it a name. And what Flashbots did is actually they created a marketplace for the democratic MEV distribution. And how does it work? Basically, they created a system that works as a plugin. So if you are an Ethereum validator, and for example, if you're using a dApp node, you can, it's the matter of clicks to actually just turn on MEV Boost. And it works like this, that there are block builders who collect transactions from the mempool and create new permutations in order to extract MEV. It also goes to Relay that takes transactions from builders and help to send them to the block proposers. And there are block proposers, so validators, who propose the block to the blockchain. And one of the theses of MEV Boost is that it's... The whole point of MEV Boost is to basically democratize MEV. And by creating that marketplace, their thesis is that with the democratization of MEV and with formalization of it, it doesn't cause that harm as it would does if it wouldn't be kind of controlled, yes? And when it comes to MEV mitigation in terms of front running, there is one very interesting proposal from Chainlink, which proposed something like Chainlink first sequencing service. And their plan basically is to take transaction from the, take kind of the timing when the transaction is submitted from their Oracle network and order these transactions by the time they were submitted, and that would create a kind of fair ordering, and front running wouldn't be possible. There is also another solution in terms of preventing front running, and actually Flashbots recently started working on that. So recently Flashbots started working on something like called Suave, and the Suave is currently under research development state, but what they mean to create is actually an infrastructure when everyone will be able to choose if I want to be front run, if I want my transaction to be encrypted, and kind of gives a variety of choice. And they also kind of do something similar what we at Shutter Network are kind of, they plan to do, what we are doing in terms of kind of shielding the mempool by Intel SGX, which allows user-level code to allocate private regions of memory. It's an enclave, and basically create a kind of mempool as a separate thing. And threshold encryption is the this is the solution that we at Shutter Network are proposing, and we are working on it. And threshold encryption basically works, is based on the keepers, which run independent nodes, and they create keys in the protocol in terms of to encrypt transactions in the mempool. So, for example, the user sends the transaction, the key is produced by the keepers, and it lands basically in the mempool encrypted by that key. And in the moment when it gets landed to the blockchain, then it's decrypted by the same keepers. And this is how Shutter Network looks like in the work. So there are just users who send a transaction, keepers, people who run Notch, which generates encryption and decryption key. And yeah, basically the whole idea is to encrypt a mempool and make it shielded so that, for example, malicious searchers, they are not able to front run or basically do malicious things. And it's worth mentioning that basically Shutter is incubated by the company called Brainbot Technologies. And Brainbot Technologies is a Web3 venture builder So if you have any interesting ideas in terms of startup development, if you have your own idea and want to actually make it live, then feel welcome to contact us. And Shutter Network is an open source project, so if you want to contribute or if you want to run a keeper, because that's also important, we will be soon gathering, or we already started gathering keepers to run these encryption nodes. So if you want to contact us in these terms, then feel welcomed. Yeah. Thank you so much.
Questions?
Thank you. Hello.
Hello.
Thank you for presentation. I'm Alexander Kvaskov. And my question is how I can check proof that transaction can be in enclave of SGX. Oh, it's impossible. I need to believe just.
Well, you mean how can you prove that the transaction is included into the SGX model?
How I can check the proof? Yeah, check that proof exists. Yeah.
To be honest with you, I don't know.
Okay, yeah. It's answer too. Thank you.
Because also keep in mind that I'm more kind of I should have said it in the beginning, but I don't have a technical background. I'm more kind of a business person. So if you'd have any questions in terms of deeper technical level, then feel welcome to go to our Telegram and ask these questions.
Hi. So you are, if you are a business person, can you tell me what I will get for running a node in a Shutter network?
So basically, running a node in Shutter works like this. So basically, where a user will submit their transaction, they will also pay a very, very small fee. And that fee will go to Keeper as a reward for encrypting the transactions.
That fee is in protocol in blockchain? Or
Yeah, because Shutter Network is a project that basically to work on, it has to be kind of a plugin into the sidechain or to the rollup. Basically the target is currently L2. And so yeah, users will pay a very small fee that will go to keepers as their reward.
So how much would it impact the price of transaction, and would it impact the time in any way?
So the price, probably for the casual user, the casual user will not even notice it. It will be very, very small. And when it comes to the latency, right? We measured latency, and it was a matter of seconds.
Who are the main income creators for Shutter Network in such a case, if users are paying slightly, really low fees?
Because basically the Shutter is not a project that will be plugged in, for example, into the DEX or into a DeFi protocol. It will be plugged in into the whole, for example, sidechain or L2. So for example, currently, we recently started working on that with Gnosis chain, on Shutterized Gnosis chain, and basically in the whole ecosystem of Gnosis, the user will be able to send encrypted transactions, and we think that will produce a significant volume in these terms.
So who is paying?
Users.
Okay.
If I understand that correctly, it was like that I'm sending encrypted transaction to keepers, yeah, and they put in blockchain my encrypted transaction and key, which decrypts that in the same block or something like that?
Basically, it gets encrypted while you submit the transactions in order to have a transaction encrypted just into the mempool, because the mempool is the place where basically malicious MEV things happen, and then automatically when it gets included into the block, then it gets decrypted. So basically, it doesn't work like these transactions will be not encrypted, for example, on Etherscan. Yeah, they will look normal. The whole point is just to prevent malicious front running and MEV.
So I need to trust keepers that they will not encrypt that before putting that in a blockchain.
Well, yes, in theory, yes.
So what is the difference between that and that Intel SMG? It's the same.
No. So basically, we think that the approach of threshold encryption is better because it's decentralized, right? The Intel SGX is just like kind of hardware produced by one company, and basically you have to trust Intel SGX. But if you trust keepers, then you trust a decentralized network of people running nodes. And basically, while trusting them, there will be also penalties in form of the slashing if they, for example, if they just behave bad. But that's kind of the worst scenario. But yeah, there will be a slashing.
That slashing is included in protocol, or someone will judge if someone.
No.
cheating?
That will be kind of there will be rules of running a keeper.
But those rules are in a protocol, or there's some people.
Yeah.
How would you compare this solution to Flashbot's private RPC? Sorry? How would you compare it to Flashbot's private RPC?
I was waiting for that question. We think that probably this solution is better because the Flashbot RPC doesn't deal with the censorship, right? Sorry?
It doesn't deal with censorship?
Yeah. What I know, yeah.
Can you elaborate on that a bit?
Sorry. No, you can ask question again, and I'm good. No. What I'm saying is that the Flashbot RPC doesn't deal with the censorship, which is also the possible, right? The type of MEV. Yeah.
Anyone else?
I have a question. You said that this solution will be a plug-in to a sidechain or L2. Does it mean the entire L2 transaction flow will have to go through this, or a user will be able to pick a shutter network or just plain?
In this stage, so in the stage of we're just implementing it, right, into the first sidechain. In the beginning, we plan just to actually test it. So at the beginning, the user will have a choice to encrypt the transaction or just go with the normal flow.
Okay, but you aim to find L2 that will accept you as a part of the official pipeline to all the transactions, right?
At the end, yes.
Okay, so if I understand, as an example before, you showed that MEV for last hour in Ethereum network was 51,000 USD. Okay, then, no, I assumed, sorry. In case users will have an option to pick whichever they pick, then validators will also have to pick either Shutter network or MEV standard suppliers. And in such case, Shutter network will have to compete with MEV.
Sorry, could you repeat the question for the last thing is?
Yes, in case users can pick, and as well validators will be able to pick if they want to use Shutter network or example given Flashbots, then Shutter network will have to pay more to validators in order for them to pick Shutter networks instead of MEV, Flashbots or any other.
Shutter doesn't pay to validators. It just pays to keepers. Right? I don't know if you meant keepers or validators.
Okay, I'm not sure.
No, I'm going to try to explain it. So basically, when the transaction is submitted and then the keepers collaborate to generate the key, then kind of the validator kind of guess this transaction, I mean, he doesn't choose, basically. Because like any of this profit comes to him. Basically, all of the profit comes from the user to the keeper.
I think the question was that since with the current architecture of things like MEV boost, validators get complete blocks. They cannot just take single transactions from things like Shatter network.
Sorry, could you repeat? Because
if the validators take like MEV optimized blocks from from MEV boost, then they cannot choose to include single transactions from Shatter network. So Shatter network would have to plug into MEV boost, but then it kind of loses the point because the transactions would have to be decrypted.
I don't know if I'm able to answer this question actually, but yeah. So basically, currently, like Shatter network is only a plug into the rollup and to the sidechain. Basically, the implementation of the L1 is just it's a very kind of broad kind of option.
Okay. And one more question from me: are the transactions actually decrypted before they make it to the chain?
Yeah.
Then the person who decrypts them and submits them has power to extract MEV from them, just like in the old system?
No, because it's not the one person only. It's kind of, the key is generated by the group of people. So they kind of, no, I wouldn't say that it's possible.
Yeah, but the last person that decrypts with the final share of the threshold decryption key, they see the transaction, right?
No.
So how do they submit it?
I mean, basically it's kind of the, I don't know if I'm able to answer this question.
If it was encrypted by a set of people, then statistically it would not be likely for that last person to be able to make that decisions, even though it would technically be possible.
Sorry, take your mic, yeah.
If the last person was to censor the transaction, it would be very unlikely, especially if it's a threshold of people, to be like submitting the transaction. For the last person to be able to censor it, it would be very unlikely.
Yeah.
So that problem would not really exist, is what I'm trying to say. Because it's a group of people. But you don't know who the last person is going to be. Yes, but you don't know who the actual group of people is and who the actual last person that submits the transaction is going to be. I'm saying that technically, even though they're incentivized to censor the transaction, you don't actually know who the last person is going to be that's going to be censoring that transaction. Therefore, that last individual, you don't actually know who it's going to be. If it's you, then maybe it's going to get censored. I don't know. That possibility exists. In that case, you could censor it. It depends on how big of the set it is. If the set is big enough, then it's not a big risk. If the set is very small, then yes, the risk is very small.
So let's say there is a group of people, as we said, and we don't know who's gonna be the last person, but what if some portion of that group, not necessarily the majority, but some portion of that group is willing to extract MEV if given the opportunity. So we don't know who's the person gonna be. I don't know whether this is gonna be me, but if this is gonna be me, then I'm ready to extract. And if like the majority of this group decides to do so, then basically the MEV is extracted anyway. And if like basically any person decides to do that, then there is always this risk that we're gonna pick this black sheep that, you know, always extracts. I don't know if that's a correct understanding of the situation.
Yes, that's a very good summary. My previous point was simply to the fact that the last person who submits like the transaction, or who actually has that choice, is to be determined in the sense that you don't actually know who it is going to be at the very beginning. And since you don't know who it is going to be at the very beginning, it's very unlikely, depending on the data set, on how many individuals are participating in this like vote, who is going to be like part of that decision. But it depends on the data set, like how many individuals are participating. So the greater the individuals are participating, the more unlikely it is going to be to happen.
Hi, this is Aris from Scroll. How does Shutter deal with OFAC compliant censorship properties, and how is it different from MEV Boost?
So in MEV Boost, you can choose relays that are both. They include OFAC list transactions, they then don't. In Shutter, basically, like taking into consideration that the mempool will be encrypted, we are kind of pro censorship resistance.
And how about the responsibility as code maintainers? Is that not an issue for Shutter?
Sorry?
The responsibility that stems from Shutter having created the code, is that not a concern of yours?
I didn't think about that, to be honest.
Good.
I don't know.
Thanks.
Yeah.
Maybe the last question.
My question is because I don't understand why I think if that last person will encrypt the transaction, he still needs to give that transaction to someone who put that transaction in block. So what is the difference between that and normal usage of it? Because the last person who decrypted the transaction that transaction needs to get to the block. So someone needs to receive that transaction and create blocks. So what is the difference? I don't understand that.
I mean, they create keys to actually like immediately encrypt it and then decrypt it, like literally at the same time when the transaction gets included into the block.
Yeah, but there are block proposals or something?
No.
So they need to give the transaction to someone who proposed a block with transaction in it.
Well, at the end, they have to submit the transaction to the validator. But once the validator produces the block, then literally at that time, that transaction gets decrypted.
Okay, so there's no difference that I will connect to the validator.
So basically,
and if I don't want to use keepers, I just need to connect to validator and send him transaction, yeah? It's exactly the same.
Sorry, could you repeat, please?
Because you say that keepers will send the decrypted transaction directly to validator. So why I cannot send my transaction encrypted directly to validator in the same way that keepers will do that?
I mean, if you can encrypt your transaction by yourself...
No, I don't need to encrypt that. If keepers will send decrypted transaction to validator, I can send decrypted transaction to validator in the same way. Why do I need keepers?
Well, because I don't understand the question in these terms that because keepers...
Sorry, to whom keepers will send decrypted transaction?
decrypted.
Decrypted transaction. To whom it will be sent?
So basically, I'm gonna put the slide again. So basically, the keepers, they collaborate in order to encrypt the transaction and then decrypt it. Like the validator, he gets the transaction also encrypted, right? And it's getting decrypted only in the moment when it gets to the block, so he doesn't have a chance to front run.
If I can just add on to this point, your concern is very valid, but it is only under the assumption of the last person who is actually submitting the transaction, which is actually a concern that happens when the amount of people that actually made the signature is very small. Meaning that the more people participate in the signature, the less relevant the actual, the less likely it is the fact that the last person who actually submits the signature is a person that would want to censor it. Meaning that if you are, let's say, a malicious party, like for a hypothetical situation, that you actually want to censor the transaction, if there's two of us, if it's me and you, and we are going to be censoring the transaction, then it's like 50-50 that you are the last person that's going to be submitting the transaction onto the network. And that there's a 50-50 chance that you're going to be the last person who submits this transaction and says, hey, I'm going to censor it. It's actually not going to go there. It's a 50-50 chance.
But I'm not talking about censorship. I'm just asking to whom that last person will send that transaction.
Who is it?
To whom? Who will receive that?
So I read a post from Shatter Network blog, and as I was suspecting, it says that this only works if it's kind of enshrined in the protocol, meaning if it's kind of natively integrated, and in case of a rollup, the sequencer signs a block with transactions that are still encrypted, and that's a commitment to that block. And in case the sequencer then deviates from that signed block, they are slashed. So they commit to a block before the contents of this block are decrypted, which I think answers all the questions.
All right, guys. Thank you very much. Thank you to Kuba.
Thank you so much.
One last question. Would you like to take the last one?
Yeah, sure.
Okay.
So yeah, let's say the transaction goes through Shutter and it's all encrypted. No one can front run it and no one can back run it in the same block, right?
Yes.
So it means that back running will happen in the next block, which will introduce paid ghost auction, which is like harmful for the chain, and everyone tries to avoid it.
Could you repeat the question, please?
Sure. Transaction goes through Shutter.
Yes.
It's successfully encrypted. No bad actors. No one can front run it. No one can back run it. So the auction to back run it will happen in the next block, paid gas auction, which is harmful for the blockchain, and everyone is trying to avoid that.
Yeah. Sorry for repeating myself, but I don't think I have an answer for that.
Thank you.
You're welcome.
Okay. Thank you. And if
Thank
you have
you.
any more questions, you can ask them later. Thank you. All right, guys, so you can feel free to enjoy pizza.